I just wanted to kind of bring this presentation to life a little bit from my perspective. From a crew perspective, I was involved probably about 4 or 5 years ago helping set up the UK chapter. And I guess, as Michelle said, the thing that appealed to me about the network was the business to business and the commercial elements. I think there's lots of networks out there, but for me, it was very much around the generation of business opportunities and real life kind of commercial activity that was going on within real estate. For those of you that don't know me, I've been in real estate for about 25 years, but very much on the commercial real estate side, so at JLL and at CBRE. But at the start of the year, I made the leap into construction in January when I joined Mace. And since then, I've been finding out about amazing projects that the company's been doing and learning about construction. So I'm not going to give an overview about the presentation because that would be far too technical for me, and Nat and Sophie are far better placed than I am. But I think the thing that appealed to me about Mace was the ethos of the company and their relentless desire to do something different and to make things better from a place and a construction perspective. And that's really what this presentation is about doing something different and doing something innovative. And that's a real ethos of the company, and it's certainly something that I've found since I joined. I've really been inspired by the massive construction projects that Mace has done, which I didn't know much about before I started. I didn't know we built the London Eye, which everybody else refused to do because they thought it couldn't be done. And we floated it in the water and lifted it up, which was just amazing. And we built the Shard, which my daughter finds, who's 7, finds fantastic that mummy works for the company that built the Shard whenever she goes up there. So it's really been inspirational for me. And at my great age, to learn new things is really what things are all about. And that's probably what Mace Tech, which is where Sophie and Natalie sit, is really all about. Is about being that little innovative kind of speedboat inside the big tanker that is Mace. And finding new ways of doing things, whether that be using technology, whether it be from a sustainability perspective, whether it be about being much more about production than construction, which is really what these two projects are about. So when Michelle and I started talking about potentially doing a Mace session, this was an obvious choice because I think it's a great topic. And also the fact that 2 of the construction managers are women. I didn't have to find women; they were just doing these jobs because obviously they were the best people for the job. So that was a great coincidence that it was 2 women leading the 2 projects. So without further ado, I'm going to hand over to Natalie, who's going to talk about our first high-rise solution project.
Fantastic, thank you, Shelley. I will just share my screen and show the sound. So I hope everyone can see that. Can you see that, everybody? Yes, great. All right, thank you very much, Michelle, for inviting me to come and talk with you. We will run through, so Sophie and I worked on 2 parallel projects at the Athletes Village, the old Athletes Village, which was the 2012 London Olympics, and the legacy is now what's called East Village. So I will talk about a project that was trialled on N08, and then Sophie is now working on N06, which is the next iteration of that. And we'll talk about how we went from one to the other and the lessons that we learned. Right. So that's us. So the aim of this presentation really is to talk about how we at Mace have stepped away from traditional construction, how we've gone about trying to create buildings from a kit of parts, and how we can also build with less waste, less vehicles, and a tighter program. Can you hear that?
We're at East Village, which is a legacy site from the London Olympics, and behind us is one of the last phases, N06, which is a private rented scheme for Get Living London.
We're bringing in 525 new homes to add to the nearly 2,000 homes that we've already got here at East Village at the Olympic Park.
N06 basically is a residential building. The thing that makes this different is the build methodology for the towers.
We are attaching the facade to the slabs before we bring them onto site, and we bring them in a module, which is then landed on in one. So as soon as your slab goes onto the deck, you also have your facade fully fitted.
HRS is an optimised logistical solution. So the first thing we do is look at the size of components that we can safely ship to site and lift into position. Once we've worked out the modularisation, we then review the engineer's design and make sure that it can all be done in the right size components for the platforms. When we assemble all these units, we put them into a BIM 360 modelling, And that enables us to track it from design through manufacture, dispatch, and then delivery to site. So we know where every component is every step of the way.
Mace built N08, which is 482 apartments just over there.
And the project N08 was where we pioneered our jump factory, and the lessons we learned from the jump factory really allowed us to understand the benefits of componentising the construction process.
What we're doing here is the first in the UK, and it's a really exciting thing to work on.
On site we get the floor plate prepared, so we use a multitude of different propping systems. We get them all set so that we have a just-in-time delivery of the unit, lifted up in a very quick time and landed onto these preset props. That then creates the working platform very quickly for the labour up on top.
We also have bathroom pods and utility cupboards that come in and get landed. And by that point, you're also working on doing all the final touches to the rebar, lining and levelling the facade, and then you start the next process again.
The benefits of Mace Tech are that it will drive the very, very fastest program, because we can predict so accurately exactly how long it takes to install every single component. So the program delivery is not only significantly faster, but it's guaranteed.
Our total aim for a completely enclosed floor, we're targeting 5.5 days. Now we believe we can actually achieve a quicker time than that, but our first goal is 5.5 days.
At the end of every week, we've got a full floor that we've built. Everyone can turn around and physically see that we're really making progress at the building.
I actually believe that the method that we're using is the way forward.
It's great to see that we're pushing the boundaries on health and safety off-site.
We're giving them quality you cannot deliver on site, and we know that because we've done it. But taking the work and the height risk away from the guys and girls who work in our job every day, that gives me a warm feeling that we are thinking in a way that protects others.
We don't need the design of the building to be bespoke for modularisation. We're able to take the design of any building and just put it together in a smarter, faster way.
When I look at what Mace are doing and the way I think they're really innovating and to some extent disrupting the sector, I think from a client perspective, we absolutely applaud that.
From the client, they get a better product, they get a better journey, they get more certainty. For me, it's a win-win.
Right. So hopefully that will give you a bit of an overview of the two projects and the two schemes, and which Sophie and I will then talk about in detail. So I'm going to talk about the Jump Factory, which is this, what you can see up on the slide here. And basically, you know, what is the Jump Factory? Well, the Jump Factory was a means to an end. So the Jump Factory is a construction methodology. And it's basically what it says on the tin. It's a factory that has been built over the start of a building. And then we use that factory to build the building inside. And each week we jack the factory up with the floor plate and we repeat the process. It's each of those factories that you saw consisted of 660 tons of steelwork. Now that's probably equivalent to about 50 London buses. Each factory was clad in a PVC membrane, so it kept it watertight and kept the wind out, and that's quite significant, which we'll talk about later. Both factories had two cranes, which are what you can see here in the yellow, two gantry cranes, so they move horizontally, and there was a 30-ton crane, which was the main crane, which would pick up from ground level, and then a 15-ton slave crane, which sat behind it. The factory had 3 trailing decks, which hang over the building, and we'll talk about what they are used for later, but they were basically for cladding, and that's quite significant as well. And then we had loading platforms at the front of the factory where we could literally drive a truck underneath the factory. The crane could drop its cable down, pick up an entire shipping container, drop it onto the loading platforms, and we could literally open the sides of the shipping container and then drive forklifts to take all the materials out straight onto the floor plate. Each week we jacked the factory up to the next floor level on 4 250-ton jacks, and they sat in the corner, and I'll talk about those in a little bit. And we had a 55-hour floor cycle. So that was our ambition, and that was basically, that's a week's floor cycle. The 55 hours aligns with a working week, but actually once we got in the swing of things, we got it down to 35 hours at best. So 35 hours of floor is actually quite significant. So as I mentioned, the whole point of the factory was to facilitate the tower construction, and we used the factory to build 2 towers, a 26 and a 30-story residential tower at East Village. The towers had a twin wall core, which was the tallest in Europe at the time, which is what you can see in sort of the black shape in the middle. We had precast floor planks, which are the numbered planks that you can see, the numbered squares you can see on that diagram, and they were stitched together with an in situ concrete topping. Precast stairs and precast columns. The columns are the red squares that you can see. Prefab utility rooms and bathroom pods, which Sophie talked about in the video that you just saw. So these are already made up rooms that are literally dropped in place, and so you've got a bathroom ready to go. We had unitized cladding, and the only change we made to the tower was the 4 corner columns, and that's because the factory's load went down those columns. So originally they were in concrete. We had to convert them to steel to enable us to take the load into the building, but we made sure that that stayed within the footprint of the original concrete column, so we didn't actually lose any floor area. But the whole premise of what we wanted to do is the factory should not dictate the form of the structure. The factory is to facilitate building the structure. And those are the 4 corner columns that you can see there in blue that we were the only changes we made to steel. So why did we do it? Well, program was a huge advantage. By having internal cranes and enclosed cranes, we could significantly reduce winding off, and that's a big problem in program on a conventional building site. We improved safety, so by having a fully enclosed space, which the PVC added to, we had a warm, dry environment, and it also removed a lot of the working from height issues because you are in a contained space at the top of the building. So a lot of those issues were taken away, and that's quite a significant. Working at height is cause of quite a number of accidents in construction, so that's a big thing as well. It supports sustainable development. Obviously, you know, the modular and off-site route is inherently more sustainable. There's less waste, but it also means just-in-time deliveries and reduced vehicles on the road. So that had a better impact on the surroundings for the residents as well. And as we say, obviously supported the industry move to modular and off-site construction. And 90% of the towers that we built the jump factory from were prefabricated. So like all good ideas, nothing's ever completely from scratch. And we drew our inspiration from a number of areas. Most people in construction are probably familiar with the jump form system for forming a core. So you have a formwork system that's either lifted up or jacked up each week. There were sort of previous examples trialed. The top right-hand corner is an example of a giant, I guess, a canopy structure that was trialed in Japan. But as you can see by the size of it, it was absolutely massive. It was supported on basically almost like tower crane sections external to the building. But as you can see there, it wasn't enclosed. So, you know, wind and rain could still get in. And then more recently, there was a Dutch initiative called a lifting shed, which is what you can see in the middle of the screen. And that was used to build a medical center. And that was because they had some very, very heavy precast components. You can see the precast facade with the punch windows. So they needed that to support they needed the cranes, which had a higher capacity to be able to lift in those components. And they in turn supported the structure, but obviously that only had a working deck level with the cranes. You didn't have the hanging platforms that we had on the jump factory. So this is a cross section through the jump factory. And what this shows you, the blue truss is obviously the steelwork, which forms the factory. And you've got the crane, which is the horizontal element here. And it shows you sort of how big it is relative to the different levels. So the support level is where all the load comes down, but we actually had the 3 hanging levels, which we talked about, which enabled us to do the cladding as well. And at this point, you can see how high the truss is above the floor slab. So it was about 20 meters above the top deck and 9 meters under hook. So we had quite a significant space in there to work with. So this shows the steel frame which formed the factory and how it related to the building structures. So the area that you can see encased in the red there, that's the floor plate of the building, which was around 26 by 27 meters, and the factory overhung that space. So the factory itself was about 41 meters by 33 meters. And again, this shows you the factory structure. This blue that we talked about was the 660 tons of steel work. But actually, if you look at the green, that was the main elements that were actually doing any structural work. So a lot of the steel work was secondary. And the main elements that you can see in the green, we've got a ring truss, which is this horizontal truss with 4 sides. And that was what the gantry cranes ran up and down on. And that tied together the roof truss. So the 2 pitch trusses supported the roof. And all the load from the entire factory went down. You see the little ring there, went down the 4 corner columns and was taken into the building at that point. So we just had a very simple support system that just took the load down the 4 corners and took it into the building. And this is the actual structure being built. So that gives you probably a clearer idea of what's happening. So you can see we've got the start of a floor plate in there. We have these white and red elements are the jacks and the climbing bar. You can see the yellow is the gantry cranes. And you can see where we started to install the PVC as well. So it's quite a complex design for the actual calculation of all the sort of individual load cases. We had to consider a number of load combinations. We had to look at all variations of wind directions, wind speeds, and where the cranes were at that time as well, plus loading out on the platforms. So the factory is actually designed to operate in storm wind speeds of 40 meters a second, and that's where you get your program advantage. We probably wouldn't lift using the gantry cranes externally in that speed, but you could still actually get up there and work in there. And we also had to look at sort of snow and temperature and things like that. And the other thing we did was we considered all the possible failure modes. So what happened, for example, if a jack lost power and shut down and we only had 3 of the jacks. So that was also a consideration. So moving back to the load path I talked about, where we said we've got the load coming down the 4 corner columns, which we used to call column trusses. That's what this slide is showing. And there was a climbing bar that was attached to the column truss, which allowed us to climb the factory up, but which also had a shoe at the bottom. And that shoe took all the load into a bracket that sat on those steel columns that we mentioned via a high strength steel pin. So the only thing that locked the entire factory to the structure was these 4 high strength steel pins. And that's the pin there with Dave, who you saw on the video, one of our senior construction managers. That pin is 250 kilograms and 230 millimeters in diameter. And that is everything that's locking the factory into the structure. And on the slide on the right, you can see the orange dot shows where the pin would go, and we have a hydraulic arm to push it into the bracket. So that's another graphic of the bracket, and you can see where the holes are for where the pin would slot through, and then the actual bracket on the right-hand side, and that's Des Mayers, who was one of the engineers involved in the design of the jump factory, just to give you an idea of the scale of it. And these brackets are really, really heavy. They're about 4 tons, and we used to have to lift them up every week and attach them to the column that was receiving the load to take that load back into the building. And this just outlines that little nib there is where all that load from the bracket is transferred back into the column. And that is probably the equivalent size of a piece of A4 paper rolled, folded in half. And if you consider that all the operational load from the factory, so all the live load from the cranes, the wind load, everything comes down on that little ledge. It's a very, very heavily stressed ledge. And that is transferred through a bearing plate, basically straight into the steel columns. So the jacks that we used were proprietary jacks. They were off-the-shelf jacks, and then we used Dorman Long, the very respected and trusted organisation. And this just gives you a bit of an idea of how we sort of progressively jacked that climbing bar we talked about up the building. It was in 500mm strokes. All the jacks were linked by a manifold, so they lifted at the same time. And the cycle takes less than an hour. And it's actually quite really eerie if you were standing on one of the other floors of the building when the factory was being jacked up, because we still kept everything going and we still worked while it was being jacked. And you'd be standing there talking to someone and watch this whole sort of 600-ton structure just very slowly glide past you. It was really quite disturbing, but also quite impressive. So I've just got a few photos here. Picture tells 1,000 words. That gives you an idea of sort of the layout of the working deck, as we called it, which is where we were building the next level of the building. So what you can see in here, you've got the jacks, the red and white structures in the middle that are being jacked out of the way, obviously, so they don't get damaged or splashed with concrete. In the foreground, you can see the rebar from the twin wall cores. The cores have already gone in there, and you can see where they're propping and decking up to receive the precast slabs. The white blobs things are where we've dropped in. These are utility cupboards and bathroom pods, so they've already been dropped in onto the floor plate below, and we just then drop the precast slabs on top of that. One of the biggest successes of the jump factory was the modular MEP. And we had what we called an H-frame, and that was merely because of the shape of it. And the H-frame sat in the core, and that was where we distributed the core services to the individual apartments. So in the photo on the left, you can see that we've still got the propping in for the precast twin wall. And as soon as those twin walls are in, an operative goes around and screws on brackets that then support what's called what we call these H-frames, which is that in the pink. So the services are already in, ready to be connected up before we've even put the next floor on. And on the right, you can see the banksman controlling the gantry crane. He's got a little power pack, so it's all he does it all from a little hydraulic power pack, which electric power pack, which they absolutely loved because they're inside in a warm, dry environment rather than outside in the open elements. And what you can see as well, sorry, circled in the pink, it's probably not so clear, but that's where we're lifting in one of the precast floor planks. So that will go in and sit on the propping that you can see there. Some more pictures of planks being dropped in place on the left, and on the right, we were actually skipping concrete into the twin walls. I think in the end we decided to pump, but initially the plan was to skip it in. This is a view looking up the factory. So I mentioned that we could lift an entire shipping container up. So that void basically is sized to a shipping container. And you can see the decked areas to the left and the right, where we would just drop the shipping containers straight onto those areas, and then they could be accessed, little ramps folded down into the building, and they could be accessed by forklifts. And this is lifting stillages up through that same space. This is a closer up picture of the services module, and you can see the crane behind it. And on the right, we've got one of the bathroom pods all ready to go, dropped in space. So we learned a lot of lessons on the jump factory. We didn't do a mock-up. The factory was the mock-up, so there was a lot of learning as we went. But we did find that, you know, as we built floor by floor, we got progressively quicker, and as the trades sort of meshed together, we improved things each time. We absolutely loved it, and the operatives loved it too, because it was a weather-protected structure. So it was a fantastic working environment. If you're scared of heights like me, and also Sophie, you actually couldn't see down, so that was quite nice. You couldn't see that you were sort of 26 stories in the air. We had a fantastic cycle time. We got down to, as we said, 35 hours at best, which is quite phenomenal. And obviously the services, the integration of the modular services was a huge win for us. There was a few things that we would have done differently. The installation and the removal, because we had so much steel work, did take quite a bit of time. And as you can see in the picture on the right, we actually used tower cranes on top of the core to help dismantle it, which probably wasn't ideal. We would reduce the number of hanging components, so we'd streamline the amount of steelwork that we had. And in an ideal scenario, when, I don't know if you can remember back to the Japanese shed that we showed you, or platform that we showed you, we'd love to be able to do something where we could jack back down, so we could retract the roof and jack back down by a structure attached to the corners of the building. Now, we weren't able to do that in this case because, as you can see in the picture in the foreground, there was we had some what we called link buildings sort of tied in, so we didn't have the ability to do that. But you know, definitely something to work on for the next time we do implement the jump factory. And I think quite significant that we'd like to support to point out here is both the jump factory and of course the next phase of that, which is the high-rise scheme, high-rise solution scheme, which Sophie's going to talk about. Couldn't have been possible without the support of our clients. They were very on board with this right from the start, and it was because of them that we were actually able to make a success of it. So, thank you very much. And I will now pass over to Sophie.
Thanks, Nat. Let me share my screen. Oh. Okay, hopefully this all goes to plan. Can everyone see that?
Yep.
Ah, brilliant. Okay, hi, my name's Sophie. I'm a construction manager. I worked on NO8 with Natalie, where the jump factory was, and I'm now on NO6, which is in the same development, but a new project where we're using high-rise solutions, which I'll talk you through. Okay, so what were the next steps after the jump factory? We needed to figure out how we made the rising factory more efficient, what have we learned, and where could we go from East Village NO8. We were lucky enough, as I said, to win the next phase in East Village. 524 apartments across 2 towers with a sky bridge and 2 tail buildings. I'm sorry, I've got someone smiling in at me through my door, so he's completely distracting me. The biggest challenge on site at NO8 was the physical construction of the rising factory. So the erection and dismantle were key to making the project a success. And the real question was, how can we streamline what we had achieved at NO8, and how short could you really turn around a cycle? Moving on from NO8, we were going from sort of the 55-hour week to the 1% gains. What can we change? How can we improve? And how can we move forward? So NO6 started well ahead of our start on site. Building a kit of parts relies really heavily on early design and coordination. We then have to procure and manufacture ahead of the usual construction project, and we create a supermarket of elements which have to be assembled off-site and then delivered to site just in time. One of the key pluses for building with high-rise solutions, and it was the same on NO8, is that we didn't need to alter the building's design to fit the modularization. We take the architect's intent and we work from there, ensuring that we maintain their intent for the building, delivering the client's vision, but in our kit of parts. So at NO6, we had several key components, and quite a few of these you'll recognize from NO8, and these all formed part of our floor build. As you saw in the video, the slab and the facade are delivered as a module. Following on from this, we also have precast columns, twin walls, solid walls, core boxes, which form the risers and the lift shafts, U-slabs, which are the core slabs, and they now have the horizontal surfaces that Nat told you about prefixed off-site. We then have the bathroom pods and the utility cupboards, which are fitted out to the state where we even have the Wi-Fi routers installed. And finally, we have 3-story vertical riser modules, which carry all the M&E services up through the building. And you can see those all there on that slide. So again, you can see how a typical slab was formed into components. A lot of work went into this before I even started on this project. And again, it's similar to the NO8 layout. Each slab has preformed holes for services. And as opposed to on NO8, when we had a full Omnia deck with the lattice slab on the top, here we only have what we refer to as stitches, which allows us to tie the slabs together, again, minimizing the time on site needed for steel tying and the amount of concrete which needed to be poured on site. So that's a bit more of a detailed drawing. Each slab has more than just the penetrations for services prefabbed into them. There was so much design that went in up front into these. The slab is divided into the solid slab, which I've highlighted, and then which is a fully cast section of the slab. And then there's the stitch, which is the part cast, which allows us to tie the two slabs together, which you can see in that L shape. It changes slightly for every single slab. We then have, in addition to that cast into this, the locators for the prop heads, which the top of the props fit into the bottom with bullets. Sleeves then for the column dowels, which connects the columns up through the building, the lifting sockets, and the facade brackets. So you can see how much detail really went into them. The slabs themselves are set out according to the locators, which are precast into them, which then set the whole geometry of the building. And the facade is set off of those locators, with a key dimension from the slab locator to the facade, which allows for a really easy install on site. And with each of the prop locations being checked before the slabs are installed, this makes it quite an easy and quite a fast cycle system. So one of the key elements of making sure that we achieve the 5-day cycle is to ensure that we have our supermarket ready, essentially. It's critical to know that each supplier has sufficient stock of the elements to ensure that we do not lose momentum. One element missing can hold us up on an entire floor, whether it's a column or a utility cupboard. Unless we have everything, we can't continue. If you use columns as an example, there are 21 columns on every floor. We've got 2 towers, and we run 4 columns per month. Oh, sorry, 21 per floor, 2 towers, and we run 4 floors per tower per month. So that runs at roughly 168 columns a month, which we need to have ready. So you can see how if we don't keep close tabs on our stock, we can run into trouble, and then you can grind to a halt, and you won't hit that key 1-week cycle of 55 hours. So here are a few pictures of what we call our supermarket. On the left, you can see a slab with the stitches being cast. Then to the right, you can see the slabs stacked and ready to be picked and have the facade attached to them. Below, you can see the gantry, similar to what we had in the rising factory, but this one obviously is an external gantry for the supermarket. And on the right, you can see the all-important columns. So in these pictures, you can see the install of the facade on the slab. What you'll notice is the first thing is that we've removed the requirement for working at height. Each slab is loaded out in preparation for the next floor's worth of modules. Our facade install team then sets about installing the facade, and it's ready for them to be brought to site. We also have a team who do all the quality checks up front before they all come to site. So we've reduced the amount of snagging that has to be done on site. Okay. So here is a short time-lapse video, which shows the assembly yard in Brandon in action. You can see here that the gantry crane travels up and down the assembly yard. Initially, we set out the slabs, which you can see going in there, picking them from the supermarket and traveling them down to the other side at one end and setting out across the yard. Then we install all the facade props, and you can see those as well, that the yellow props that have been fitted onto the slabs. And finally, we prepare and install the unitized panels, including the GRC, and then load them onto a wagon ready to be brought to site. Oops, sorry. Okay, so after the design, the next element is, which is critical for us, is really the logistics. We rely so heavily on both our on-site and off-site logistics teams to make sure we can run a smooth day on site. If deliveries didn't arrive on time and weren't through the gate on the half hour when we needed them, we wouldn't hit our daily install target. In a similar way to missing a column, a late delivery can be problematic. Some days we're targeting 20 arctics and a full floor of slabs coming through the door. And if one leaves late by an hour, it can throw the whole day off and you end up missing the target for the 55 hours. Next, after logistics, the next key element is the lifting team. So once the vehicles are through the gate, it's down to the install team. Where we have to lift everything, it's the lift team that really can make or break a cycle. Here are some pictures. On the left, you can see an external unit being lifted into site and onto the props below. And on the right, you can see the U slab with the corridor module going in there with the horizontal MEP services, which get fixed off-site. So, oh, cranky. I've had problems with this. Hang on, let me try and reshuffle this. I'm not sure if this is going to work. Sorry, guys. Let me just put this on. Can you guys see that? Yeah? All right. So we beat the 55-hour cycle and we run a comfortable 5-day cycle now. And I'll just show you the video. I hope it works. I've had some problems with it, which will just run through, it quickly recaps NOA and then it'll take you through the 55-hour cycle. Okay, so this just takes you back to NO8 and it's a bit of a time lapse of one of our slabs there. There's the lattice slabs that go in and it's a full slab pour. And one of the key changes that we've made now, that we do the facade and a full pour slab with a stitch on it. So what I'll try and do, keep up with this, but it's harder than you would think, is just talk you through the weekly sequence. So, the first and most important activity to kick off the cycle is to install all the internal and external slabs in one day. And it's critical. This is where you need your deliveries coming in every half hour. And you can see there, that's done. My tower was done on a Tuesday, the other tower we did on a Thursday. The next activity is all the boxes, form the rise and the lift shafts, solid walls, spin wall, and you start installing the stitches. So cable tying and getting that first all important stitch course in, you start setting out the props. Next up, installing the columns and getting that second stitch cord so that we're ready to install the new slabs, which go into the core and have those horizontal modules that I spoke to you about. And then finally, last but not least, utility cupboards and bathroom pumps, and that's how we finish the week. So you can see how all of those elements, it can be quite onerous on your logistics to make sure that you get everything done on time. Just flick back, sorry about that. Okay, so what is next? We are going to be taking pods one step further and trying kitchen modules. A couple of weeks ago, we lifted 2 fully fitted out and tiled kitchens into the shell and core sequence on one of our top floors, which is a massive gain to fit out if we can achieve it and roll it out from now on. We're also looking at developing some pre-service walls, which we're trialing on a couple of floors on one of the lower buildings here. So pros and cons, no on-site assembly of the jump factory meant a much shorter learning curve and will mean a swifter closeout for shell and core. We've shaved half a day off from our cycle. Our target was 55 hours. We hit 50 comfortably. We've managed to reduce the number of lifts by the crane and the vehicles through the gates and guaranteed programming quality. The biggest con, however, is the rain and the wind. Never underestimate the joy of working on a high-rise building in the middle of winter in a very large tent. Okay, that's everything from me. Thanks.
Thanks, Sophie. I think I could watch that time-lapse video over and over and over.
So much pressure talking along to it. It's because it goes quite quickly.
You have to talk quite quickly, right? Yeah, that's fantastic. That's fantastic. Thank you, and Natalie, for your presentation. As Shelley mentioned, presenting technical content is not easy, and you have done it seamlessly today. So thank you for highlighting the tough parts and the straightforward parts and all of the in-between. These are amazing initiatives, and we're happy to champion your message today, so thank you. I'm going to go ahead and open up the chat. We welcome your questions. We want this to be an opportunity for Natalie and Sophie to highlight more details and specifics about the project. So
can I start with one, Michelle?
Yeah.
Talk to me a little bit about the partnering with the client. How easy is it to persuade a client to sort of take a calculated risk and try something different? How did you manage that?
Oh Lord, that was certainly before my time. I think we're really lucky with Qatari Diara and Delancey. We have a relationship with the team down here in East Village. I'm not sure how they managed to get them to agree to the jump factory, but after the jump factory, high-rise solutions was something that they were really keen to get involved in.
It's something I wasn't involved in the early stages, but I mean, I imagine, you know, selling them sort of all the benefits of it's kind of a no-brainer really, because the risk and the cost was on us at the end of the day, because it was a construction solution. You know, they were getting the end product, so the risk and the cost was with Mace. So I guess there was no sort of, other than any risk to program, which we demonstrated that we could deliver, there was no real risk to the client.
I just wanted to compliment Shelley's question. That was just recapping. I think it was 13 weeks that was saved on the. You tell Natalie, how many weeks have been saved
so on the actual
far?
Yeah, so on the program when the Jump Factory was in full flow, the intention was to save 13 weeks off the program. We had a couple of issues either side with the actual dismantle and removal, but I think I'm not sure where we sat in the longer term with that. I don't know if you know, Sophie. I think overall we were neutral. So.
Yeah, 13 weeks translates to a lot of money. So, right, speed to market. Well done. I'm going to read a couple questions. We've got 3 so far. Sophie, great presentation. How are the modules held in place before the stitching concrete is poured? Good question.
The horizontal modules, so the horizontal modules are held in place on a U-beam, which is a concrete U-beam, which is precast. And then they're rested onto the lift boxes and the solid walls and the twin walls. So those get poured before the stitches. So those get poured ongoing throughout the week. And by the time you put the U-beam on it, they've all been poured the whole way up. So they're poured onto a fully formed wall, if that makes sense.
Okay, we'll let Joel come back if he has a further question. Dave Abrams, my favorite projects to watch. Do the riser modules stack way through them, or are they attached? My apologies. Are they attached to the concrete structure too?
We've got channels precast into the core walls, which they are attached into. So they slide down and connect onto each other, but then they're fixed back into the concrete structure.
Okay. Next question. How does this help with sustainability? Which, Shelley, this is one of the key elements that, as you and I were talking about programming earlier this year, we wanted a technical project to present, and we wanted something that spoke to sustainability, and this is certainly one of them. Pam, great question. Pam's in from Connecticut. Welcome from Connecticut. Thank you for your question. So, Natalie or Sophie, do you want to take that one in terms of the sustainability piece?
Either or.
Either or. Yeah, I mean, at the end of the day, it's about modular and off-site, which Soph's probably better placed to talk about.
It's reduced. We have reduced waste. We've got reduced packaging. Sustainability-wise, it's a step in the right direction to making sort of us a far more sustainable construction site. I think it's just less vehicles, all of those sort of elements come together.
Shorter build time, yeah.
Yeah.
And I think we're looking at using,
impact to the community.
Yeah, absolutely. So that was, and East Village, that was a big thing because you already had residents that were living there post Olympic Games. So these plots were being developed quite later. And so a lot of them were not too happy, I guess, about suddenly living on a building site. So the amount of time, by minimizing the impact in terms of deliveries, in terms of build time, and also noisy works made a huge difference. I think you were quite involved with the community there, weren't you, Soph?
Yeah, and it was good. It's even on this project, being able to have a fully formed visually as well. It's so important to both the projects, N08 and N06, visually look really good as you're going up with a complete building, as opposed to residents staring at a building site for 2 years. And
then moving forward, I understand you HRS are looking at using Simply Concrete as well, aren't they, in some of their solutions? So it's something we're constantly, net zero carbon is a huge thing for Mace, and it's something that we're constantly looking to refine with each iteration of HRS projects or Mace Tech projects. And I think that's the next step is looking at Simply Concrete.
Santini has a great question, which Natalie, I think you and I spoke about as we were preparing for today, and that is, there are occasions where deliveries didn't turn up on time and work was halted, right? So the cadence and the sequencing of all the activities, Sophie, you mentioned this, that things were clockwork, precision.
It's a lot. When you reduce it to as minimal deliveries as we do, it becomes more and more difficult to shift things around and sort of problem solve any of those issues. On NO8, we were working to 15-minute delivery intervals because we had cranes and each tower would have something coming through the doors every 15 minutes to get off the wagons and get going. On NO6 now, we're down to sort of half an hour every hour kind of thing. So we've sort of rationalized that slightly more. You can kind of get away with it with slabs and things like that. We stack pods on site now ahead of the floor slab to try and mitigate any of those issues. So any of the long lead items, we try and keep closer to site so that we don't have that issue. The key ones really are the floor slabs, and you just kind of have to wait that one out and hope that you can regain that speed through the day.
Yeah, I mean, and just to answer Santini's question, I think it's a combination of phasing, staging, having areas to plop things down as questions are being addressed, and or being upfront, and in terms of planning, the criticalness of understanding the blocks, the dominoes in a row, and what happens, right? I mean, that's all the quality assurance and the analysis that's up front. Imagine there's a lot of time and effort put into that.
Yeah, we also had distribution yards, so we had sort of, stuff was coming from all around the UK and even overseas, but would have centres closer, just sort of outside the M25, closer to London, so that reduced a lot of that risk, and then the stuff would come from closer in rather than Scotland or Ireland, or even I think you've got some Belgian. Do you have a Belgian subcontractor on?
Yes.
Yes. Yeah. So how the use of sort of distribution centres really helps with that as well. But there's still you still got to plan the deliveries. You got to plan around roadworks and all that kind of stuff.
Well, this is the due diligence and the analysis. Even looking at the geography and topography outside of your immediate site, and how do you move the modular components from point A to B, and what happens when something. It's a really good point. It's call that risk management recovery time, right? I'm going to move to the next question, if that's okay. How did the project manage? I'm assuming this person is saying, how did the project management or project manager maintain exclusion zones when lifting so many materials over the floor areas? It's a really good question.
So
Good question.
I don't know, there was a legit exclusion zone, and we only lifted in small areas on NO8. Again, here, it's the same way you would manage any lifting. It's still installing things by crane. So we've got a whole road, we've got pick points, they're all maintained exclusion zones. It's the kind of standard stuff we do, all the daily action briefings, all the exclusion zone notices. It's no different than any regular site really in that respect.
Yeah, I mean, what I would add with the jump factory, you're only lifting in one dimension. So you're only lifting over a small, like the trucks would drive underneath, or whatever we were lifting, you were just directly underneath, because it's just a vertical hook. You're not slowing around like a tower crane. So you had very limited areas that you were lifting. And then we also had, just-in-time logistics. So get it all right and it works quite seamlessly.
So if I'm going to take you back, bouncing back to the Q&A piece of the webinar, not necessarily the chat, so apologies for going back and forth. Willie Shaw's asked a question: how much earlier did the supply chain become involved against a standard project, right? So we talked about that, early analysis, due diligence, pre-planning, and did that put pressure on the procurement and their buy-in to work with these new techniques? That was something I was thinking about as well. How did the collaboration come about in pre-planning and due diligence in terms of suppliers?
So I know with our partner on the project PCE, I think they've been talking to them for sort of years and bringing this up, and we did some work over at Battersea. We sort of trialed the HRS slabs and things like that. So it's been going on in the background. The whole time we were doing NO8, we were essentially developing the next project. So everything's been brought in over a long period of time. It's not kind of your sort of traditional way that you would build. So we've been putting it, the guys who work in the senior team have been working on this a lot longer than we've been working on NO6, and then sort of getting the precast and all of those guys in. I mean, things like the bathroom pods and the utility cupboards, they're pretty standard, I think, across quite a lot of British construction. I'm not sure about in America. But so the company that we use, Deba, they always get in as early as we got them in this time anyway, because they manufacture them earlier and up front. But definitely the precast, it was a case of getting out there, getting the design sorted, and building those relationships with people very, very early on. I couldn't give you an exact time because I wasn't actually on the project at that point when they were doing that.
Sophie, we're going to call that thinking time. There was great thinking time and a great deal of collaboration that went into it. Gavin Westbrooks asked a really great question. How well did the design team adapt to the modular system design compared to their usual way of working? That's a really good one too.
That one for you, Lee.
Well, I suppose it's an either or one. I mean, both these projects were design and build projects, but again, I mean, in terms of what we did on the jump factory wasn't anything too hugely sort of extraordinary. I think what you've done, Sophie, is a lot. You know, what you've done is a unique product to Mace. What we did on the jump factory was sort of used existing products, so it wasn't anything that the design teams were sort of hugely unfamiliar with, but they were all on board. I suppose it's like everything, you get everyone involved and let them, you know, make everyone feel that their concerns are being listened to, and it's a collaborative approach. So we didn't really get any resistance from design teams as far as I'm aware on the jump factory.
Yeah, again, it's that concept of speed to market. Everybody wants to design and get it done faster and move on to the next project, right?
Yeah, and I think also, you know, everyone's interested in innovation. Everyone wants to come along on that journey, and it's, you know, with the Jump Factory, we won so many awards that everyone was sort of being promoted on the back of it, and everyone was really happy to have been involved. So it's the way the industry is going. I think if you meet resistance, then perhaps they're not going forward the way the industry should be and is going. I don't know if you have anything to add, Soph.
No, I think especially, well, when we started NOA, sort of it is just all the standard elements that have been prefab before that we've brought together in one system. And we started with FDL, who was our frame contractor on NOA, all started the journey together. And then by the end, once you got to the top, we all sort of, you stand at the top of the building and you think, why would we build this any other way? The same for HRS. The 2 floors were absolute murder, but roof now. And I was having this conversation with Dave, my boss, the other week, and I said, I don't think I could go back to traditional. I think you'd go mad if you were standing there sort of putting up formwork, doing all of this. You'd go absolutely mad. You wouldn't, it's nonsensical to build anyway, but this really.
We have time for just one more question, Natalie, which I think is geared more towards you as the structural. Does the use of modular elements limit the ability to optimize the sizing of elements? So
sizing, okay, I presume the question is around
first floor columns being the same
different loading conditions.
30, right.
Yeah, no, again, I mean, limitations with sizing, the only limitations we had with sizing for what we did with the jump factory in the towers was the ability to lift them, to transport and lift them in place. You could step down the column sizes as you went up. So we had double lift precast columns. So, you know, we could actually drop down in terms of size as you got less load coming on them. I think maybe with the core walls, they probably dropped down in thickness, Soph, I think. So they went up the building. But in terms of, you know, it really, once it's all stitched together, it's acting as a regular concrete structure. So like I said, the only limitations were what we could physically transport and lift.
I think we're at the end of our hour. I just want to say thank you so much to the two of you. This has been exceptional. On behalf of Crew UK, as I mentioned earlier, we're excited to showcase innovative projects, innovative construction concepts, and to also showcase the energy and the effort and the, like I said, thinking time, brain power that goes into all of this. You did an exceptional job showcasing. So thank you so much. We appreciate it. And to all of our attendees, thanks for listening today. And please watch this space for more Crew UK events. We'll see you soon. Thank you.